Let's say I decide to delete this file from my computer. Now tell me, do you think that the information in this file has actually been deleted? Before I answer this question, let me clarify the term information. Information in physics means properties of particles, such as the spin, charge, or even color of the particle. Okay, so now that we clarified the term information, let's get back to our question. So, no, the information in this file has not actually been destroyed. This is because, much like the first law in thermodynamics, there is a law in quantum mechanics that says information cannot be destroyed, it can only be transferred. So the information in the file that I deleted has not actually been destroyed. It has been ejected out of the computer and transferred into heat. Anyway, this law holds true everywhere in the universe except for one place, in a black hole. In 1974, Stephen Hawking discovered that black holes emit the Hawking radiation and slowly evaporate and destroy all the information that it contains. This violates the information law that we mentioned earlier, which leads to the black hole information paradox. This paradox angered a lot of quantum scientists, such as Leonard Susskind, and what he did was that he tried to solve this paradox, and we will definitely talk about his attempt later. But for now, let's talk about Jacob Bekenstein. So, we all know that black holes contain information, but the information in the black hole is hidden. And we refer to that hidden information as entropy. What Bekenstein did was he found a way to calculate the amount of entropy that a black hole contains. He found that the amount of entropy that a black hole contains is equal to the surface area of the event horizon of a black hole, which is this part of the black hole. This was quite unusual as it meant that information entering a black hole will not actually go inside the black hole and fill up the black hole's volume like pouring water in a glass, but it will actually stay there and be stored on the event horizon of the black hole. So the bits of information entering a black hole will just be pasted here instead of going inside. Okay, so now that we have explained what Bekenstein did, let's move on to what Susskind did, which was solve the black hole information paradox. Let's say you have two astronauts in space, let's call them Alice and Bob, and Alice falls into a black hole. As she falls through the event horizon, nothing particularly interesting happens. She doesn't get hurt or anything like that. But what happened to Bekenstein's theory that we mentioned earlier? Shouldn't Alice have been ripped apart and glued on the event horizon? Well, she was. Let me explain. And let's look at the incident in Bob's perspective. Okay, so when Alice fell in the black hole, Bob was standing outside and saw her get ripped apart and shredded and glued on the event horizon, like we said earlier. But which perspective is correct? Well, according to Leonard Susskind, they both are. So, what happened was that when Alice passed the event horizon, she was shredded and hot glued on it, like we said in Bekenstein's theory and in Bob's perspective. So, essentially, everything that will be happening inside the black hole that Alice will be experiencing will just be a hologram of the information engraved on the event horizon of the black hole. What Susskind later realized was that this does not only apply to a black hole, but applies to the whole universe. Everything that we're experiencing in 3 dimensions is just a projection of the information that has been engraved on a distant 2 dimensional object in the universe.